So before I start, what did we use in the olden days when it comes to lighting? Before candles. Go outside, you see it in the day. Sunlight. How did you bring a sun into the house? I'll give you an idea. Start with the F. Fire. Didn't we have fire in the house? I'm talking about Vikings time. So we're the Vikings now. A fire. They burned the fire. Then as technology went on, did you know that they put some paraffin in there, then the little candle will burn on the paraffin? Paraffin, you know paraffin? Or maybe a bit of a turf. They burn like little, I won't say petrol because there's a lot of fumes there. Paraffin is a type of, like diesel. They burn a little piece of string in the diesel, that sucks it up, and the little string will burn, and there's your little light. So in the olden days, someone used to walk outside and light all the candles outside. Then technology changed and we got light. You guys happy with light? What is light? Well, obviously it's a dark sucker. It sucks the darkness out of the light and it gives us something to look at. Now, as technology grew, incandescence was used for many moons. And then fluorescence became popular. And then today, LEDs are popular. You guys happy with that? So technology has changed. But now, is all light the same color? No. Now, you guys are cleverer than me. You get like warm white and ice cool and all that type of colors? Yeah. Right. Which one is a warmy one? Now, which one to give you a bit of a winter effect, a cooler one? Yeah, you guys got codes. Now, that code is right, but the code depends on the manufacturer. Is that right? So, let's look at the basics of light. If I stand here and you all can see me, you all see me, the luminous flux from you to me is enough so you can see me. But the luminous flux is between me and you, not from me to the working surface. So a light gives off a wattage. Is that right? And that wattage could be heat. 60 watt, 12 watt, 4 watt. Now, many moons ago, before the Vikings maybe, they used to compare it with amount of, maybe after the Vikings maybe, candela. So we compare that light as a 12 candle light. In other words, it's compared to 12 candles. But prior to that, we used to compare light with the sun after they invented candles. So if I say to you, the strength of the light today, you all agree we say it's wattage. But in the olden days, we used to call it candela, candles. And we still refer back to candela. So in other words, the luminous intensity, the strength of the light is in candela. Is that all right with you guys? If I stand here and you look at me and you can see me, the luminous flux in lumens is good. Now, if I go down the steps, is it true that we want enough lumens per square meter or the illumination on the surface to be strong enough? Now that is your lux, as we know it. Have you guys ever heard about a lux meter? But also lumens per square meter. So the amount of lumens on a square meter surface. Now guys, that is the three definitions you must know. They can ask you that. Now anywhere there, I can meet or measure the intensity of the light. But normally we measure that on a working surface. Now, the working surface could be your table or the steps where you walk, correct? Now, if I say to you, go measure the lumens or the lux in a hallway where you're going to walk. Now, guys, I don't know about you guys. Have you guys ever seen people who takes that meter, hold it in their hand, and they do this, and they see where I walk? Guys, when you walk down the steps, do you look 1 meter down or do you look on the ground? The right way is to put it on the ground because that is the surface where you're going to walk. But But in average, people just hold it in their hands and they walk around with that. But if I ask you to work out the strength of the light where you stand or when you work in the office, is it true that you're going to put it here on the table and measure the strength of the light? So the strength of the light on the working surface, is it candles, lumens, or lux? Lux. What about if I say lumens per square meter? Is that also lux? All right. That is the hardest when it comes to light. Now it's easy stuff. Happy? Cool. Right. I'm going to teach you three numbers. 200, 400, or 800. 248 or 246. Happy? Right. If I say to you the toilet, do you need a lot of light there or not so large? So that's about 200 lux. Got it? In the stairway, do I need a lot of light? 200. In the kitchen, do I need a lot of light? Yes, that's about 400. Dining room, I want to see what I want, 400. In the office box, about 400. Yeah, where we sit, about 400. Right. What do you guys think is a jewelry shop where mommy wants to buy the bling blings, daddy wants to buy the bling blings for mommy? All right, I'll give you some easy one. Remember, 246 is about 600 to 800 watts. Lumens. I'll try again. Lux. The reason I put this down is that in the exam, they give you a scenario and they say roughly how many lux will be in that environment. So, what is 200 doubled? What's 400 doubled? So remember, 248. Right. Now, kitchen. Bathroom. 200. Maybe 400, because you want to see your toenails, eh? Right. What about in your workshop where you're going to work with dedicated electronic components? 800. So guys, in New Zealand, there's no standard. So I had to go and Google that. All right? But unfortunately, they asked that in the exam. So, just to recap, in a classroom where you sit, it's about 400. Where you don't need the light, like passages, about 200. Right, you're sitting in a TV room watching TV. If you just want a little light, you put on 200. But if you want at least sit there and sit and chat with the family, you want to see the kids playing and inside, you pump it up to 400. So a normal house will be either 200 or 400. How's that sound? You can have a dimmer. Oh, that will come with a bit of a wine and a good movie, eh? Yes. Right. So guys, unfortunately, they're going to ask you this lumen strength. You just have to say, is it 200, 400, or 600, or 800? That will give you one of the answers. So I want to summarize it by saying, where you think you don't need that light, it's about 200. Where you do need the light, but you don't need to sell something nice, it's about 400. And then above that will be the bling blings, or farmers, or Kmart, where they want to sell it by the color. You got it? Easy. Right, have you guys ever heard about a halogen light? Can you touch it? Why not? Right, why can't I touch a halogen light? Right, I see people writing good things down. Right, now two things or three things happen with the halogen light. Firstly, when it works, it gets very hot. Happy? What happens with you when you touch something which is going to be very hot? It's going to burn you. So that's one of the reasons. But that is not the most important reason. So when you're going to install a halogen light, you can't touch the glass because the glass is made out of quartz. It's a very clear crystal light. The oil on your fingers will be lying on top of the glass. And when the glass gets switched on, it gets very hot. That oils will deteriorate the parts where it lies on the glass. It will crack the glass and you have to throw the glass away eventually. You can wipe it, but be careful. You can't just wipe it with an oil rag. you understand what I mean? Yes, wipe it, clean it, etc. So guys, this halogen light has got two little end caps where you connect it to something. That end cap is normally made out of like a porcelain, ceramic. We can't make it plastic. Why? What's going to happen with the plastic? It's going to melt. Why? It gets so hot. Right, guys? And there's a word I put down there. It's called regeneration cycle. So this halogen tube inside, the gases turns around inside that halogen tube. And by the way, what type of gas is inside the halogen tube? Halogen. And now that glows, and that cycle in which the gases turn is called the halogen cycle. Right? Not enough for that. So, question, can you touch it? No. Why? What's your fingers going to do? The oil, right? And that's what I wrote in the middle paragraph. Your oil will cause little cracks on the glass and eventually dump it. Okay with that? Cool. Right, guys, what do we call this lamp? Is it a fluorescent or an incandescent? Incandescent. Now, this incandescent has got two types of connections. It's called an Edison screw or a bayonet cap. Is that right? Which one of the two, left or right, is polarity conscious? Left. You all agree the one which you screw in, well done, Clayton. The one you screw in, the left-hand side has got the positive or the phase at the bottom, and your neutral is the side. The one on the right, doesn't matter which way. Happy? Now, guys, I haven't heard this yet, but if you look at the globe, why do you think it's that pear shape? A, because it gives off great light, or B, it reduces glare. It reduces glare. Do you all know what's glare? Is glare the brightness of the light, or B, that the reflection in the eye? That's right. Now, there's a couple of ways to reduce glare. And don't say, I wear sunglasses. All right? Right. To reduce glare, there's a couple of ways. I can make my tube looking like an opal. That's one. Or, what about put a reflector on? You see, every fluorescent's got like a funny plastic around it. Or you guys call it the diffuser. Right, that diffuser will reduce glare as well. But there's another way how to reduce glare. Just put it high. Higher you go, you got no problem. Right? Right, so nice little things like that. So, guys, have you guys ever seen this one? Is this a neon light, incandescent light, or a fluorescent light? Fluorescent. Now, if you look at this fluorescent, there's certain parts on it. Can you identify the fuse? Right, can you identify the ballast? Can you identify the tube? Can you identify the starter? And can you identify the capacitor? Now, this fluorescent has got two capacitors. One between phase and neutral, which is there for power factor correction. And another one inside the starter to reduce radio interferences. In other words, it takes that arcing noise away until you don't hear it on your TV or on your radio. Okay? Right. This fluorescent, important. If you throw this cap away, it will still work. The starter is only needed when the starting process is in place. When the starter or the light is shining, then you can remove this and the light will continue to work because the path of least resistance is through the tube, not through the starter circuit. Now, what do you guys think is the purpose of the ballast? A, to switch on the tube. B, to reduce the current to the light. Well, in fact, it's got both answers. It helps to start the light and it limits the current flow. Right? Now, I'm going to explain to you the working operation. When I switch the power on, current will flow in the tube through the ballast, through the earth electrodes, or try again, the electrodes inside the lamp, through the starter, all the way through the other electrode to neutral. So that happens very quick. Remember, I'm breaking it down in microseconds. Now, once that happened, can you see that I put a ring around the starter? What happens now, inside there's a bimetal strip. And the bimetal strip is getting hot and it's going to open. You guys with me? Now, while that happens, what you don't know, the magnetic field in the ballast is also rising. So at the same time, the field's getting stronger inside the ballast. When the starter opens, the whole system technically switches off, right? But because of this magnetic field in the ballast is dropping through itself, self-induction causes a voltage strike through the lamp, and that makes the lamp glow.
Is that why they flicker sometimes?
Yeah, it hasn't got enough heat in the tube, and then there's enough heat. You guys with me?
But sometimes they turn on instantly.
Yep. Look, normally when it starts immediately is when it's a brand new tube and there's a lot of gases in there and everything is in good condition. And also, it's also possible that the voltage it strikes with is getting weaker because the ballast is getting tired. But what's very important, when this starts, that starter opens the circuit. While that circuit opens, this will strike through the lamp and the light will work. Now my question is, what do you think happens if I take the fuse away? Will it work? What about if the ballast is broken? Will it work? What about if the tube is stuffed? Will it work? What about if this goes on, off, on, off, on, off, on, off, on, off? What could be wrong? Starter. And I asked that in the exam. What can be wrong? What can be wrong? What can be wrong?
So much that can go wrong.
Think about what you do in the real world, right? They don't ask too much about it. The hardest question is what I explained to you, what I explained to you guys in the wording below that. So what I just explained in the wordings, which I took away. Beg your pardon? That will not be one of the answers. Right, guys? Can you see that I said switch on, ballast, through the tube, through the starter, through everything? Now, there's a magnetic field in the ballast. There's a magnetic field. Oh, sorry. The starter gets hot. Starter opens. When the starter opens, this built-up magnetic field will collapse and ignite the light. So what they do, can you see there's 1, 2, 3, 4, 5, 6 little bullet points. They can put it in any order, and you must tell me which is the right order.
So if anything's faulty, it'll go off apart from the starter.
Correct.
And it'll just flicker if it's the starter.
Correct. And there's one more. If you look at the fluorescent and the ends get gray, it tells you actually the lamp starts saying goodbye. Happy with that? So, it's not too hard. Now, what's the purpose of the ballast? Two things. It helps striking the lamp and it reduces the current through the circuit. What's the purpose of the starter? Obviously, it starts the light. What's the purpose of the cap between phase and neutral? Power factor correction. What's the purpose of the cap in the starter? Reduce noise or the EMI. That's it. Nothing more. What color is a fluorescent light tube glowing? White? White? Cool white? Yeah. Right. There we are. Right, guys. This is a sodium vapor high pressure lamp. It's got a choke, cap, igniter, and a sodium vapor high pressure lamp. The choke is in series. See there? In series with this lamp. The igniter is in series and parallel. The cap is in parallel. The lamp is in parallel. For some reason, they asked that in the exam.
What's up with series and parallel?
Oh, sorry?
What's up with being in series?
All right. So that igniter is in series and in parallel. In parallel, there's a built-in cap, and in series, there's a coil. That's why it's connected. That's why it's working that way. So, guys, in the exam, I know this is a hard part. A lot of people actually say, this is so hard, I can't remember this because I don't use these lights anymore. They're going to ask you, the ballast is always in series. The lamp is always in parallel. The capacitor for power factor correction is always in. Well, if you can remember that, the rest might be parallel or series. Right, look at this one. This is your mercury vapor. Your mercury vapor is a white light. The sodium vapor is like a yellowish light. Right, now the ballast, is it in series or in parallel, the choke? The capacitor isn't, the light isn't. There we are. Now the question is, if they don't give you the circuit, then you're going to guess, because you don't remember how the mercury circuit is. You understand what I mean? Now guys, the top one is sodium vapor high pressure. You normally get that in warehouses or maybe street lights. The mercury vapor is also in street lights or in the warehouses. The difference between the two, the bottom one, the mercury vapor gives you a nice white light, where the other one is actually more bit of a yellowish light. Right, now let's look at this. Street lights. I use LEDs for street lights. Oh, I think so. Does LEDs used in offices? Does LEDs used in houses? LEDs in warehouse lighting and security lights? Yeah. Is it true that LEDs can be used anywhere today? Right. What about a sodium vapor high pressure? Right, sodium vapor high pressure could be street lights, and we won't put it in houses and stuff like that. And warehouse, maybe security, but not necessarily, but you can if you want to. Mercury vapor, same. Street lights, warehouses. Right, what about a fluorescent? Will we use it in street lights? Nah. Offices? Yeah. Housing? Yeah. Warehouse lighting? Not necessary. Remember, warehouse is normally high, right? Incandescents. Where will I use the old incandescent? Houses? Offices? Yes. Right, guys, sodium vapor, low pressure. Now, a low pressure just means it's a very orangey light, and it's just good for one thing, security. It's good for security. Now I'm going to give you the colors so you can actually see why I said all this, which I just mentioned. So, the color for LEDs, is it true it can be any color of the rainbow? You can choose it. You can make it red, pink, green, orange, blue. In other words, it gives you the full spectrum. Right. What about a sodium vapor high pressure? So you agree that the LED could be any color. You can choose, but normally white, right? Right, there is two ones. There's a warm white and a cool white. Is it true your incandescents can do the same? Is it true that your LEDs can do the same? The latest LED, you can actually select it on the ballast or on the light itself. Right, guys? So your sodium vapor high pressure is normally a yellow color. Look, there's a street lights. Can you see the left-hand side is your sodium vapor high pressure? The right-hand side will be your LEDs or your mercury vapor. You see the difference? Right. Now, a metal halide, it's a combination of a sodium vapor high pressure and a mercury. So all the difference in the tube, it's got more metal in. The ballast and the starter look like sodium vapor, but the light is normally more white than yellowish. So the right-hand side one could have been metal halide. But metal halide is a mixture between sodium vapor and mercury vapor. Some bugger just joined them and made money out of it. Right. Look at this one. Mercury vapor. It's normally white in color, right? Right. Fluorescence. Is it true that fluorescence is normally white in color as well? But you can get it in cool and warm white and that's right. Right, guys, incandescent, again, yellow, whitish, right? Now here comes the last one. Sodium vapor, low pressure. You must probably been at the polish and you see that U-bend tube. Now that problem with that one for low pressure, it gives off a very, very bright yellow. But that lights are excellent for movement. So if you stand here and you've got sodium vapor low pressure all around your house, you see a rat running around. But the biggest problem with color, it takes color away. If I take my shirt and I go to mercury vapor, you'll see the green and the blue and the pink and all that colors. But if you go to a sodium vapor low pressure, you'll see that my colors are all brown on my shirt. It doesn't matter what color you've got, everything will look like brownish color. So we say the color rendering is bad. It renders, in other words, it fades colors away. So think about this. A light orange, which is like warm white, and a white like mercury will bring good colors out. Make sense? So the color rendering is great. That's it. Nothing more. So what are the factors which will affect the lifespan of any light? Is it true that I need a good position to mount it? I don't want to bump it every 5 minutes with my head because it's not going to last. Right, guys? Is it true that if you're going to keep it in a vibrated place, it's not going to last long? Cool? What about ventilation? If it gets too hot, too hot, too hot, too hot, cracks the glows. Right. Vibration of the variation of the voltage to 30, to 20, to 80, to 30, it changes. The lamp's not going to last long enough, right? And for good light, you need strong enough 12 watt, 6 watt, or 4 watt LED. What are the LED size you get now? 9 watts? You get 12? Right, I'll tell you, I made a mistake. I've got 3.5 by or 4 by 4 meter bedroom, spare bedrooms, 3 of them. And when I did my house, I told the Sparky I want 4 12 watt or 9 watt LEDs. Bloody hell, I need sunglasses when I walk in that bedroom at night. Now the wife said dimmer, bad electrician. I used the wrong amount of light. Should have taken 2, but that's okay. So guys, is it true that you can overkill it by putting it too strong? But always listen to the mummies, eh? Otherwise there's trouble. Right, guys, what about glare? Is it true that good light will have low glare? If you guys stand and look at me, does the light shine in your eyes? Not so much. So the glare is not bad at all, right? Right, guys? Uniform intensity. In other words, if you put a 60 watt, a 40 watt, and a 20 watt, and a 60 watt, and a 40 watt, and a 20 watt, is it true that your colors will be different, or your wattages will be, the strength will be different? Well, if you want to pee mommy off, do that. And the last one is the right color. Have you guys ever installed LEDs where you actually didn't check the selector switch? It's yellow, 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 white, 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 yellow, yellow, white. You know what that means? Oh, bugger, I have to go over. Right. So guys, what they do in the exam, they chat 4 at the top and 4 at the bottom, and they swap it over. And they say, which of the following as will extend the life of the lamp? Will glare, will color, will the strength of the light? No. It's the voltage, the ventilation, and the way how the light's installed. The reason why installation is bad and good, if you look in your environment, how is fluorescence installed? Horizontal or vertical? Read instructions. It says horizontal. If you take an incandescent lamp will give you the most life if it's installed upside down. But if you can install it to the side, you'll see that the element is going to start sagging and it doesn't last as long. So here comes the term, manufacturer specification. Follow that. Right, there is color rendering. Use the right light, the right color, and you'll be able to see other colors. Now, can you see the left-hand side? I put a warm white clover or LED, and the right-hand side, I put a LED, ice cool or whatever light in. Can you see that you can see different colors? Now, if you've got a place where it's always cold, like a South Island, it's always recommended to put the warm white in because it always gives you that warmer feeling. In a place where it's hot, you won't believe it, put the cool one in. It's just a color, but it plays with the brain, believe it or not. But you know what? Keep mommy happy. Give her what she wants. The right color though, not what you're going to think. Right. Cool. Have you guys ever heard about the term stroboscopic effect? Have you guys ever seen when there's a light flickering, it gives you the optical illusion that something is standing still, which turns? Have you guys ever driven with a car? When you look next to you at the traffic light, a car comes in and you can see that the wheel rim is actually turning backwards. That is a type of stroboscopic effect. Stroboscopic effect is the optical illusion when there's a gas light and something is turning, it will look like that thing is actually standing still. So what happens if you touch it? It can kill you. It can rip your arm off. It's bad? Yes. How are we going to prevent that? That is the exam question. So guys, stroboscopic effect is the optical illusion which tells you that something could stand still, but in fact it's turning. Now, what caused that? Gas discharge lights, like fluorescence and sodium vapors and mercury vapors. LEDs, no. Incandescents, no. But a light with a gas inside will cause that. What happens is the gas is a bit of a slow motion flickering. We know that electricity goes 50 times a second, right? But with gas, it actually recycles all the time. So that recycling is a little bit slower. And what happens is that's synchronized with something which turns. And when that flickering and movement becomes the same frequency, it looks like it stands still.
What if it wasn't flickering?
If it wasn't, then you won't see, then you'll see the wheel is turning.
So it's only if the light is flickering.
The gas, all gas discharge lamps cause that. Mercury vapor, fluorescence, sodium vapor. Don't Google accidents because stroboscopic have killed a lot of people. Now, how are we going to reduce stroboscopic effect? Right, there's 3 answers we always love to hear. Firstly, if you've got fluorescence, put one on red, one on white, one on blue. One on red, one on white, one on blue. Then you have them all 120 degrees out of phase with each other, and it can reduce stroboscopic effect. Secondly, take your ballast or your tube. Inside that fluorescent or incandescent, I try to get sodium vapors. There were capacitors in them. Remember the power factor correction cap? Take that cap and change them. Make them 120 microfarad, 30 microfarad, 16 microfarad. And that will change the phase angle, and that will reduce stroboscopic effect as well. And the last one is when you have a lathe with people who's working on a machine, put the incandescent lamp close by, and that will also take the stroboscopic away. Got it?
If you're going to go and change the capacitors, may as well just change the light.
Exactly. And the best is LEDs can prove it, but in the olden days, workshops had sodium vapor or mercury vapor or fluorescence, and that's called stroboscopic effect.
So they constantly flicking naturally, or is it just when
It hurts frequently.
Yeah, but we can't notice it. We just think it's normal light.
You will see it, but when you do, if you go to a lathe, you switch it on, you can see that wheel turning. It looks like it's standing still. And when you touch it, you're dead because you're not thinking. It gives you the idea it's actually standing still. All right? Or even slowly backwards. You say, why is it going backwards? When you try to stop it, it takes your hand off. Right, guys? This question popped up in the exam. Nobody knows why. And they force you to use Pythagoras. So I'm just going to run through this one. And it's actually not hard. Have you guys ever heard about Pythagoras? A squared, B squared, C squared. Right? Now I'm going to go through slowly. I'm going to talk to the computer and I'm going to teach you something. Is it correct to say that when that light shines, the best light is at A? You guys happy? The strongest light will be at A. As you go further away, it becomes dimmer. Do you know that that angle will determine how strong the light is at the end? Bigger that angle over there, it means poor light. Closest, stronger and stronger. So that means, can you see that that one sprays there to there? So that is a good area. Right. So when you look at the light, firstly, they can ask you, what is the strength of the light at A? Now, this is unfortunately a formula you will not get on your formula sheet. E is what we want to calculate, is I divided by the height squared cos theta. I'm going to show you that all now in slow motion. Firstly, do you all agree that that's the height A? You guys happy? I is the strength of the light measured in candles. And the angle down is 1. There we are. So what are we going to do? 1,200 candles. divided by the height, 6.5 meters square. The cos theta is 1 because it's straight down. And there's your answer, 28.4 lux or lumens per square meter. So what I just did there, what is the lux, the strength of the light on the surface? It is the strength of the light divided by the height squared. But because it's straight down, the power factor is 1. Or the phase angle is 1 because it is 90 degrees down, it's straight down, so the phase angle is 1. So that becomes 1. Now guys, a lot of people will only remember that. They don't want to do the next one because it can be tougher. All what I'm going to do now, if I say to you that is 6.5 meters and that is 3 meters, can I use Pythagoras to work out this length? A squared, B squared, give me C squared. Right. There's a formula for that. Sine, cos, tan, and all that lovely things. Right. So before I do that, if I work out the length of C for the next question, this length, is it true that there's a new angle there? Adjacent over hypotenuse. Have you ever heard about Sokotoa? Right. So what I'm going to do here, first, I put down Pythagoras, A squared, B squared, square root. That is to work out C. So A is 6.5 square, B is 3 meters square, and that tells me that length of C is 7.16 meters. So guys, can you see that from there to there, it was 6.5. Is it true that now it becomes 7 meters? That 28 will be a little bit less. So you can guess the answer if they give you 3. Will it be more than 28? Will it be less than 28? So you can guess the less than 28 one. So that is a way you can choose. But to work it out, there we are. To work out the cos of that angle is adjacent over hypotenuse, which is your Sokotoa. And what I do, I take the 6.5 divided by the 7.16. That's the easiest way to remember, adjacent over hypotenuse. Right? And that will give you a phase angle, with my mouse there, of 0.91. And all what I need to do is replace that with cos theta. So there we are. What is I? I is 1,200, gentlemen and ladies. What is the height? Height is 7.16. And then that answer is 0.91 multiplied with. In other words, it's not 100%, it's 91% of the real value. So there we are. Put the values in, and look, it's 21.3 lux. And gentlemen, this, and ladies, is most probably the worst lighting nightmare you can get.
Can you just put H for height?
Yes, I just made it as simple as possible. H is your height, either straight down.
I over H cos theta?
Yes.
That's it.
And I don't even use the word cos theta. I just say angle, 0.91 or 0.1. So either 1 or whatever angle you give it to. Remember, adjacent over hypotenuse. Now, this calculation, I'm going to redo again when I'm going to do a bit of Pythagoras questions with you in a couple of weeks' time.
Pythagoras going to come up in the exam.
You've got about a 0.5% chance to get anything like that. That's why if I say to you, go practice this, it's going to be a hard practice maybe for 1 mark. If you think you don't want to mess with this, leave it out. Or alternatively, go and practice it. I personally think this is not hard. But you know what's the hardest part about this? Is that bloody formula. E lux equals I candles divided by height square angle.
Height squared.
Height squared, yep. The squared of height. Right. Any questions? I told you lights will not be too long. So gentlemen and ladies,